Hello, Science Niners. Sorry we can't have a regular class today. We're doing interesting science experiments and seeing interesting chemical reactions, but this is going to be the next best thing, and we're going to have some online class. So before we get into some new stuff, I want to go over some old stuff that we looked at before spring break. So we're going to be doing a little bit of Science 9 chemistry review. So one of the things that we talked about before spring break and before all this kind of craziness has occurred, we talked about a little bit about the kinetic molecular theory. If we remember that kinetic means just moving, molecular means molecule, and theory is like kind of an idea. So it just means the moving particle theory. And what it says is that all matter is made up of these tiny little particles, and all these tiny little particles are moving around and bumping into each other. And there's lots and lots of empty spaces in between these particles. Um, and as we said, these particles are always moving, even if it's something like a solid, they just move much less. And the more energy the particle has, the faster they move and the further apart they can get. So gases typically have a lot more energy than something like a solid. Okay. Before we also talked about how solids have a fixed volume and shape. Liquids have a fixed volume, but not a fixed shape. And these do not have a fixed volume and do not have a fixed shape. Now, a lot of people in class got hung up on the word fixed, as in thinking, now fixed means, in this case, it has a couple of different meanings, and a lot of people thought it just meant if something is broken, you can fix it. But fixed means not changing. So for this right here, if you just left a solid by itself, it shouldn't be changing its shape, and it will not be changing its volume. So we say it's a fixed volume, fixed shape, because it's not changing. For this liquid right here, it has a fixed volume. That means, say, if this was in a beaker and it said like 50 mils right here, it's not going to be going above or below 50 mils as long as this thing stays closed. Now, so what we say is that it has a fixed volume, but it does not have a fixed shape because this can flow and move around. This doesn't, for gases, it does not have a fixed volume, and it also does not have a fixed shape either. One of the things that we also talked about before the break is changes of state. When enough energy is added to a solid, it can change to a liquid, and when enough energy is added to a liquid, it can become a gas. So this is time on the bottom. I'm just going to put in some numbers here. So let's imagine this is 0, that's 5 minutes. Say let's say 10 minutes. That's 15. Let's say this is 20 minutes. Let's say this one is 30 minutes way over here, and let's say this is 40 minutes way over here. So between 0 and 5 minutes, this thing is solid. Okay, so between 0 and 5 minutes, when it is going on the increase, it is solid, and that's it. Now between 5 and 15 minutes, so this time right here, 5 and 15 minutes, it is in a process that is called melting. Okay, between 15 minutes and 20 minutes, so in this whole time period right there, so between 15 and 20 minutes, it's completely melted and it's just hanging out as a liquid. Now, between 20 minutes and 30 minutes, 20 minutes to 30 minutes, it is boiling. And then after 30 minutes, it is completely boiled and it is a gas. So 30 minutes on, it's just a gas. So our changes of state, so where it's changing from one phase to another phase, is this time right here and this time right here. And you can always find a change of state because it is the flat spot on a graph. So here's a flat spot on a graph and here's another flat spot on a graph. So those are changes of state. Now, if something hypothetically went from a solid to a gas, and there's a few substances that do go from solid to gases, it would look like this. This would be your solid, and this would be your gas. Now, what we also talked about here, this flat spot right here, is not called melting, it's not called boiling. It gets a special name when it skips the liquid state, and that is called sublimation. When it goes in the reverse direction, it is called deposition. And that's going from gas back to solid, but here it's called sublimation. There's a few substances that do that. CO2 does that. You can have what is solid CO2, which is sometimes called dry ice, and then it doesn't melt, it just goes straight into a gas. We often do an experiment with like caffeine that will go from solid to gas. It doesn't have a liquid state. And a lot of people get confused when they hear about caffeine doesn't have a liquid state because they're like, oh, I've seen it in coffee and energy drinks and stuff like that. There's a difference between having caffeine in a liquid state and caffeine dissolved in water. So when caffeine is in coffee, when caffeine is in an energy drink or Coca-Cola or something like that, it's just simply dissolved in, well, Coca-Cola or Pepsi or coffee or an energy drink is mostly water. Okay, so it's just the caffeine is just dissolved in water. That doesn't count for being liquid. Liquid is like when it actually gets heated up and it melts. Anyways. We also talked about physical changes. A physical change is when it just changes state, okay, or changes shape or something like that. So here was our example of a physical change, and what we see right here is that we started off with this particle right here, and it looks exactly the same. Before, it was all just over in this area right here, and now it's just spread out. But as you can still see, it's still 2 H's and 1 O. Okay, so molecularly speaking, it's the same thing. It just kind of changed its shape, or in other words, it went from a solid to a liquid, and so we call that a physical change. Now this is different from a chemical change, which actually the atoms change locations and combine with something different. So here we have a sodium, an oxygen, and a hydrogen. A sodium, an oxygen, and a hydrogen. Okay, and it's going to react with a hydrogen and a chlorine. Hydrogen and a chlorine right there. Now, Na, O, and H are all bonded together, and what's going to happen is they move around, and we lost some of these guys way over here, but what we see here is that those things were switched their locations and have now combined with different elements. So next thing that we talked about before spring break was what an ion is. An ion is when an atom loses or gains an electron. Remember, electrons are negative, okay? So if it gains an electron, it is gaining negatives, which will then make the atom negative because it's gaining a whole bunch of negatives. And if it loses electron, it's losing negatives, which will then in turn leave the atom positive. So for something like calcium, calcium loses 2 electrons, so loses 2 electrons. E negative means electrons, so it loses 2 electrons and becomes Ca2 plus, and then it loses those 2 electrons and these go flying away and do some chemical reactions and stuff like that, but it leaves it positive. And that's how calcium does this. So metals usually lose electrons, and nonmetals gain electrons. So again, right here we have this notes right here, and we said that lithium is a metal. If an atom loses an electron, becomes positive. We have that right in there. And this happens only to metals. They lose so they can have a full shell. So normally lithium looks like this. Remember, it has 2 electrons in the first shell. And then since it has a total of 3 electrons, here's its outer shell. It wants to have a full shell. And if we remember that the shells go 2, 8, 8. So as a maximum number, so it has 2 as a maximum number of electrons in the first shell, 8 in the second, and then 8 in the third. So this one loses an electron, and therefore becomes, it always loses the outside electron first, and it has 3 protons, and since it lost one of its electrons, it has 2 electrons in there, so it has 3 protons, which are positive, and now it only has 2 electrons, which are negative, so that gives it an overall charge of +1. Okay, and that's why we see it has that +1 charge right there.